Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 9 from the January 2022 Pure Mathematics P4 International A-Level Edexcel paper. This question A is asking us to find the derivative with respect to y of this function. 1 over 1 plus 2 times ln y all squared. Now, first of all, I'm going to rewrite this as 1 plus 2 times ln y to the power of negative 2. Writing the index form so that you got this in the numerator. Now I'm going to differentiate this function, differentiate this expression here, 1 plus 2 ln y to the power of minus 2, and I'm going to differentiate with respect to y. So there's no implicit differentiation involved here because I'm differentiating with respect to y, which is the same variable in here. So you can use the chain rule for this. You multiply by the power, so you have 2 times, or negative 2 times, 1 plus 2 ln y. Then you take 1 from the power, that goes to the power of negative 3. And then you multiply by the differential of what's inside the function. So you multiply by the differential of what's inside this function, and the differential of 1 plus 2 ln y is, well, the differential of 1 is 0, and the differential of 2 ln y is 2 over y. It's 2 times 1 over y. So we end up with our expression, the differentiated expression, becoming minus 4, you could say, over y times 1 plus 2 ln y to the power of 3. Okay, so that's the differentiated expression for 9 part A. Okay, now we're going to move on to 9 part B. And now for part B of this question, it says, hence, using what we just did, which is this differential, find a general solution for the differential equation as follows. So we got to use this answer somehow, so that's why I've got it written down over here so that we can refer to it when needed. Now, to solve this differential equation, we have to basically get rid of the dy dx. A differential equation is an equation which has dy dx in it, and we have to end up having just y's and x's in it. In this question, it doesn't say for us to give it in a particular form like y equals something, but as long as we have an equation which has x's and y's in it, we have solved the differential equation. Okay, so now, for us to be able to do that, what I'm going to do first to make life easier is I'm going to rewrite this cosec 2x as 1 over sine 2x. So this will be 3 over the sine of 2x dy dx equals y 1 plus 2 ln y cubed. Now, in order to get rid of this dy dx, what I have to do is I have to integrate both sides with respect to x. So I'm going to integrate this side with respect to x, but because I did that to this side, I have to do the same to the other side. So now the dx's cancel out over here, and now I've got this differential equation where on the side that says dy, I should have all the y terms. On the side that says dx, I need to have all the x terms. So I can do some rearranging here, and I'll write this as 3 over y times 1 plus 2 ln y cubed. That's going to be integrated with respect to y, equals, and on this side I'm going to have the integral of sine of 2x with respect to x. Now, using what we have found in the last part of the question, which I think I'm going to have to use it now, I can see that the integral, if I go in the reverse order, the integral of this is going to give me that. Now, what I have here looks very similar to this, except it has a minus 4 and this has a 3. So what I'm going to do is I'm going to take this differential equation and I'm going to multiply both sides by negative 4. I'll multiply both sides by negative 4, and then what I'll do is I'll write the 3 on the outside, and on the inside I'll write the negative 4. I have negative 4 over y times 1 plus 2 ln of y cubed. That's got to be integrated with respect to y, and this side will be minus 4 times the integral of sine of 2x with respect to x. Why did I multiply by minus 4 both sides? Because it doesn't change the whole equation, but it makes this look exactly like what we got when we differentiated that. So the integral of what we've written here is going to be exactly what we started to differentiate in part A. So I can now write this in an integrated form. This is going to be 3 times, and this is going to be now 1 over 1 plus 2 ln y squared, okay, equals, and now if I integrate sine of 2x, I'm going to get minus cosine of 2x, then divided by the differential what's inside there, which is 2. Okay, and then that's going to be plus c, because we've got the general solution here. We don't have any numbers to put in, so we put plus c. Now I've basically done what I have to do. I can kind of simplify a bit. So this is going to be 3 over 1 plus 2 ln y, that's all squared, equals minus 4 times minus a half, gives you 2 basically. They cancel out, positive 2 times the cosine of 2x plus c. Now I can leave my answer like that. I don't need to make the answer y equals. In fact, that's going to be in the last part of the question. So in this particular part of the question, I can leave my answer like that, and that's perfectly fine, because it just says find a general solution, meaning get rid of the dy dx and express it in terms of y and x. So I have y and x here. I don't have to write it as y equals any particular form. It didn't mention that. Right, so this is perfectly fine for me to leave my answer in this form. Now for the last part of the question, I'm going to use this. So I'm going to take this over.